Implementing USB and SOC projects can be tricky. You have to start with a good foundation. Hi, I'm Terry Moore from MCCI. Let's talk about USB. I've heard many decision makers say, I chose USB because I wanted it to be simple. That's a good idea, but the simplicity of USB that we find in products like thumb drives, keyboards, and mice is the result of a lot of hard work and careful planning. When you do your own SOC or custom ASIC, you take on the system-level responsibility for a myriad of detailed design decisions. You have to get them all right. What are these decisions? Let's start with the basics. Is your product going to be a USB device, a USB host, or is it perhaps going to change roles, being both device and host at different times? Your product will be talking to a USB host or device. Let's call that the peer. How much data throughput must your product have to its peer? And when talking to the peer, what software will you be running on the peer? Will you be providing that software? Will you be running the OS vendor software? Will you be running third-party software? Will you be running a mix of all these things? What device classes do you want to support? USB has on the order of a dozen different device classes. Are you using the new Type-C connector? If so, will you be supporting USB power delivery? How will you test? The list goes on and on. It's important that everyone in the decision-making chain have a clear understanding of the consequences of each decision. For most companies, USB is important to the project, but it's probably not the most important thing. Maybe it's only used for debugging or firmware download in production, but it has to work. You may have no business case for building a team of USB experts in-house. This makes it all the more important to choose the right partners early in the design cycle. The success of your project depends on informed decision-making throughout the development process. Why is USB so tricky compared to something like an Ethernet controller? The reason is architectural. Ethernet controllers are designed to do one thing well: layer 2 handling of Ethernet frames. All multiplexing, retries, routing, etc. happen at higher levels, typically in software. Unlike Ethernet, USB host and device controllers directly implement much of this higher level functionality in hardware. This means that software is less able to intervene and work around errors, and errors are unavoidable. The hardware portions of Chapter 9 functionality must work, or USB communication will be impossible. SOC designs generally rely on purchased design blocks, so-called IP blocks, for modules like the USB controllers. There are three kinds of design blocks for USB. There are host controller interfaces, there are device controller interfaces, and there are dual role interfaces, sometimes called on-the-go or OTG, which can switch between host and device. Let's say that you decided you want to support high-speed USB. Now you have to select your host controller block or your device controller block. When selecting a host controller block, there are industry standard register sets. EHCI and XHCI both support high-speed USB 2.0. XHCI also supports the faster speeds of USB 3 and USB 4. However, the value of a standard register set depends entirely on the firmware you intend to run on your product. If using a commercial operating system, you may have to choose register sets that are standard based on what your operating system supports. However, you may find that non-standard register sets require less of silicon area and therefore justify adopting a non-standard solution. When selecting a device controller block, you don't get the choice. There is no standard for USB device controller register sets. So you will have to make sure there is software support available for your selected IP block. Because of this variation, MCCI works closely with Synopsys, Cadence, Faraday, Sci5, and others to ensure that our USB system software supports the IP blocks that are commonly used in the industry. After licensing your USB IP block, you then have to integrate it with your system. Integration involves configuring the IP block and generating the RTL based on the selected configuration. You should be aware that this configuration must be correct or you won't meet the requirements of your design. A misconfigured USB IP block may compile, but it won't give adequate performance. Worst case, it might not work at all. MCCI has seen many projects delayed by innocent decisions made during system integration because the decision maker was not aware of the overall requirements of the system, particularly the system software. The good news is MCCI has been working with semiconductor companies for over 20 years, assisting with the development of complex USB products. We have an unmatched depth of experience and know-how and pretty good software too. We understand that a big part of what we do is helping customers make the key decisions and serving as a long-term repository of design knowledge and know-how. That's all we have time for now. Check our website, mcci.com, for more information on our products and services. Thanks very much for your time.